All right. Thanks for listening and subscribing. Uh, I guess I really don't mind beating a dead horse to death. I'm just not gonna beat a live one. Um, beat a dead horse to death. Yeah, I don't mind beating a dead horse to death. Really, there ain't much else to do. I should just try to get into it quickly while I still can. Sean Carroll, I think, did mention in his podcast with the evolutionist that there is nothing really, I think it was him at least, that there was nothing really that justifies um, anything past the physical that isn't really associated without the psyche, without like psychological associations. Um, and that's, I mean, that's probably pretty correct. I mean, in terms of what I'm trying to angle, like my angle is just, I mean, there should at least be a common language among people to be able to understand cosmic theories or earthly, earthbound theories, earthbound knowledge. And I mean, that's kind of my uh, terminology when I use separation, like in terms of the separation, like there can't be any separation between the a theory of everything or subatomics. And yeah, I get that. It's just um, it's just really a lot more complicated than I mean when you're trying to basically understand mathematics with language or language with mathematics, it's not going to be like necessarily a good fight. I guess both competitors are just going to be in complete opposition. So there's going to be complete opposition with the language and mathematics is what I'm saying, and I don't think that. I mean, I definitely don't hesitate to say that that would. I agree. I agree that it would start at um, kinetic energy because that doesn't work experimentally. But in terms of the theory of everything, yeah, I'm still a little bit. I mean, I'm definitely still hesitant to say like, well, I mean, I'm not in any. I don't believe that you can just give things properties and then be able to weigh everything, as in newtons and kilograms, and have any expectation to develop or innovate that knowledge. So I'm not saying I don't really necessarily think that that was Newton's mistake. I think maybe on his part that it was due diligence. But the fact of the matter is that yes, kinetic energy, 1/2 mv squared, uh, creates the theory of everything, or creates a theory of everything, or creates subatomics, or sort of turns anything philosophical about cosmology or earthbound elements or properties. It just everything sort of gets left behind, and then you have like a chase. Um, you got to like understand. I mean, just right off the bat, you got to understand how much Earth weighs. You got to understand how much the mountain weighs. Understand how much the moon weighs, and I don't even have to look up on the internet, and I know that there'll already be answers for that. And it's just because of all of these constants, like the gravitational constant, or the Planck constant, or the relativistic wave function. And my my stance is still, I mean, I don't like. I don't really like Einstein. I'm not saying he was like perfect throughout his whole career. I don't think he stuck to things very like wholeheartedly. I think he was definitely passive and I think I do sort of tend to uh, migrate towards the idea that yeah, the Bohr atom was basically what uh, sort of killed cosmological constant. Uh, Schrodinger sort of killed cosmological constant. Yet, if you know, yes, if cosmological constant was more of a philosophical construct. Okay, just the fact that he wrote uh, a book talking about an alternate religion, like a religion, an alternative to religion that doesn't include fear or God. Okay, and to be that atheistic about something, and also uh, sort of elaborating on the idea that cosmological science will not end. And so that goes back to the problem with Newton, and that goes back to why kinetic energy, mass equals, sorry, one half mass times velocity squared could essentially just be a quantum theory, meaning a subatomic theory. Now, I'm just saying, just because like this, just because pi, the square root of a circle. I mean, I'm really that terrible with calculus and all that terminology, but trigonometry or whatever. But just because pi is essentially the diameter or the radius of the whole circle, and it's never ending because you cannot you cannot find the actual radius of a circle. Just because it's never ending, like it's still going on today. Um, they're still trying to find it after how many years? 100 years? Who knows? It has to do with like de-Sitter, this de-Sitter space, and then you get into the Minkowski space, and then you have your hyperboloid, and that's all it really jumps around to. Like it's all about this de-Sitter space and the conformal theory, which is all of the mathematics, or it's anti-de-Sitter space, and somehow they contrive um, certain dualities or certain distances or certain speeds according what they say according to Albert Einstein. So I'm not. I mean, I'm just going to be skeptical of that. Just because, yeah, I think Einstein was a little bit smarter than having a theory of everything, or if he was trying to explain, I don't say the word general, or sorry, I don't say the word bent gravity or bent space. I just say general relativity or special relativity. So I think he understood that relativistically, that elementally, the subatomics would have to expand the further they got out into space, because that was the only thing that really seemed to work. Um, you can see clouds cause rain, but what goes above the clouds, and then what is happening, when you look out into space, and these types of questions, you have to. I mean, if you are talking um, elemental fibers, so to speak, of the dark matter or the cosmic soup or anything like that, these particles, these bits of matter or momentum or work or energy, I mean, all of these things have to be, you have to be kind of I mean, it's pretty understandable. I mean, you can say that, yeah, there has to be more like in proximity to gravity. So if I have a greater proximity to gravity, which is Earth, then yeah, there should be more bits. If I'm above the clouds, if I'm above the rain clouds, and I know that there's still outer space above the rain clouds, um, there should be less bits. Uh, so to me, does that equal some type of work? Like, is that some fuel for the universe? Does the universe run off of that mechanic? Uh, and to me, unfortunately, that is the truth, that you can't have a theory of everything without the properties of without everything being compromised essentially by uh, this gravity. Whatever is happening with the gravity, like a theory of everything, unfortunately, in my opinion, has to be compromised by gravity. So gravity, essentially, there's an extreme amount of force bits that are keeping Earth intact, and they're eroding or whatever. Decaying is what I guess is the correct terminology. And then there's less outside of it. And then there's the moon, and the moon has like an extreme amount of force bits holding the moon together. Um, and so yeah, that drag or that orbit of the moon can be considered both a push, or it can be a push, and essentially, like relativistically, you could say it could also be a push and a pull. I mean, it doesn't change anything. If it's a push, then it's still energy and work. It's still yeah, it's still a grounded theory. If the moon is being pushed, okay, or if the moon is pushing and being pushed, it's still a grounded theory. If the Earth is being pushed, it's still a grounded theory. If they're being pulled, it's still a grounded theory. And I'm just saying that I think there's probably a very futile disagreement between all, like, considering that Einstein did have a Newtonian philosophical, more of a Newtonian mechanical universe. Like, say, two constants. Say, like, you have your mass constant squared. You can just be talking about the moon and the push that the moon is actually doing to be able to orbit, and the push that is drag is the drag force. So it's essentially what is pushing behind the moon, and the moon pushing. So that would be like a push. Um, and so that can be like two type of velocities essentially. I mean, so I'm just saying that's how I'm looking at E equals mc squared, or a cosmological constant. Um, I just look at Einstein's theories that way. I don't look at his theories like they're pure insanity, like a gravitational, or like a Planck constant, or Schrodinger, or something like that. I'm just looking at them like, well, I'd say that's pretty justified. I mean, it doesn't tear down like a Cartesian. I mean, it definitely doesn't tear down a Cartesian development or like innovation to physics. It doesn't really tear down um, what is it? Yeah, Newton's properties, or like the principle of reflection, and then yeah, but yeah, maybe I just don't like uh, Cartesian or Cartesian, is that how you say it? Descartesian like philosophical principles. Maybe I don't believe, or well, I choose not to believe that there is um like a philosophical hierarchy that we have to achieve. I mean, that's sort of what I've uh really tried to instill in myself, is that yeah, there's not going to be a great answer. There's just mostly going to be a failure. And I don't think that that is Cartesian or Newtonian, let alone Einsteinian. But I think Einstein, or Frankenstein, whatever you want to call him, was like a little bit. He was a little bit on to that, especially in terms of the atheistic argument. In terms of yeah, don't propose a theory of everything. So I'm just saying E equals MC squared is not a theory of everything. Today, that's what I'm saying. But the kinetic energy, I wouldn't even say is a theory of everything. It might be like it's all okay again, like reconciliation with the fact that I don't believe that Newton's mechanics were fully mathematical. I don't think that they were. I don't think they could have been a standard um, to a theory of everything. I mean, that's just crazy. So if you're trying to disprove religion, I mean, in a sense, you kind of need religion to have some sort of opposition. Like in this sense, this Platonian kinetic energy. Okay, so string theory to me, or rope theory, or umbilical cord theory, or um, hourglass theory. I mean, it's not representable of too much, especially just because you're trying to just prove gravity, and you're not going to be able to prove gravity with a Cartesian philosophical standard. You're not going to be able to prove gravity. Okay, so you can have gravity within force, but you can't have a exact force of gravity, if you catch my drift. Like there shouldn't be a gravitational constant, and if there is one, it's going to be a mathematical sort of gimmick that just squeezes by the psyche. Like it's just good enough for the psyche. I mean, these models, just I mean, the model of the model of like why would Einstein and Eddington why would Einstein and Eddington be talking about stars that were like just so far away during a solar eclipse? Like, don't you think Einstein and Eddington would have been talking about the solar eclipse like during the solar eclipse? Like, why would they be talking about like whatever, fire, in the fire in space, hydrogen in space, like a million billion miles away, like on the day of a solar eclipse? Because that would be essentially essentially the worst time to look at the stars could be during a solar eclipse. So it doesn't make any sense. Like I guess the internet models, they don't make any sense. And yeah, um, yeah, I'm not really gonna say he like was like bought and sold. I mean, I'm being like pretty aggressive saying that, but yeah, why not? Um, and this whole thing with Newton, and he's like the king of rocketry. Um, I mean, yeah, there's probably a lot to that. I'm just saying essentially will always be a de facto. Like there will always be a de facto, and it looks like it is because this has to be like the property of science is everything, and it can never end. So I don't disagree with string theory. I like string theory. I like my hourglass theory. I just thought my hourglass theory was a little bit more um, is a little bit more animated, just because there's masses out in space, or sorry, there's masses and there's particles, um, and it's different than just equating everything into one uh, thing, especially since there is always space. Because when the say when the particles become less and less, like how is that stretching? How is that elasticity happening? Like if something is moving, if there is a spaceship moving through space, how are the subatomics, bits, particles in quantum field theory? How are those? How do those represent? How would a string represent elasticity in that way? I just don't think that it can be torsion. Um, so far, I mean, because yeah, you can represent like a tiny moment in time. There is torsion, and if you have cohesion in a representation of a spaceship moving through outer space, and those little bits stretching and pulling apart, that I mean that can only happen for so long, because I guess I don't know if it was said like you can either only transfer energy or you can only transfer maybe what is the invisible. Like you can only there can only be transfers between subatomic particles. There can only be transfers between what is quantum mechanical, or what the bits are made out of, or the atoms. So it just doesn't make any sense to me that the bits in space would transfer into the spaceship, even though that is Cartesian law. Like that is the Cartesian law. That is the Descartesian principle, that there is this constant transfer of that force, of that work, or of that energy, or of that pressure. But that just is way too, yeah. It's like I mean, is that not order? Is that not order out of chaos? Like that's all that really essentially is just order out of chaos. So, like, if I'm not implored to say, okay, like I'm touching the pen, but I'm really not touching the pen because I'm not I'm not fully like understanding the subatomics. Well, then I disagree with your Descartesian uh, principles. Like I just will not. I don't think I will not be a like a bystander, like a bystander, or like a something like a I don't know like I'm not like the John Malkovich or something. Like I'm not watching my own movie and there's a bunch of electrons watching my movie. I'm just not going to go there. So if that is disappointing, that's completely fine. But again, if I don't do physics, if that means I'm not doing physics, that means I'm not doing physics. I really don't care. It's just a theory of everything, and to me, that's a religious theory. That's a cosmic religion. So whether or not cosmic religion was promoted, or it was asserted that there would be an alternate religion as opposed to um, this whatever, like common religion is. Like there would be a scientific creation story, which there essentially is now. Okay, scientific creationism and um, intelligent design, these things. Why would it? What in the world would implore me to want to be a physicist if I can't have my own philosophical understanding? If your philosophical principle, your philosophical principle is to climb the hierarchy of needs forever, I'm not going to do that. I'm going to say, fuck you. My force is my force, or you know, my gravity is my gravity. I'm not like I'm not gonna attach a bunch of umbilical cords to um, these universal laws that that don't really have much like that. I mean, you can't see you'll never be able to see an atom or a subatomic or a bit or a particle. Like you can say you can almost say that the photons are just made up of many bits. Okay, I think and then yeah, it just grows. Okay, so there's more. So you have bits, and then uh, you have a charge, and then you have more bits, and that creates the photons. And yeah, so I like all that. So maybe I'm not really debating physics, and that's completely fine. But yeah, I'm not gonna implore myself too much. I mean, I'm not gonna like go too crazy with this stuff. Even that wave theory is ever really even that wave theory is ever really disproven. Um, all right, so yeah, the theory of everything is just horrible. It's just um, it pays no attention to the real facts. So I mean, yeah, if you have to have Cartesian law, Cartesian principles, philosophical Descartian philosophical principles, I'm out. I'm not gonna play that game to some advantage that I see as completely futile. So I mean, I mean, if it doesn't elaborate into uh, real life, the real world, then yeah, I'll point out how I don't like it. So I don't think I can really do much more than that. And so that should just I'll just try to recap if you're still there. So you have object, mass, and weight. So objects, mass, and weight are the big question. We're not concerned about shape. Shape doesn't matter if it's anything like that. It's a different subject. It can't be about the Big Bang or nuclear fission can't exist in electricity. I don't know. It can only exist. It can only exist in like nebulas or whatever. So I just don't agree. I don't agree with all that. I agree that we should be skeptics and we should try to learn, but no. The static state Big Bang theory is a good. It's a good starting point for all of this elementary stuff. But yeah, you're going to have a relativistic understanding of the universe if you're going to use subatomics, if you're going to use bits. So there's just going to have to be more bits. Um, I don't really understand why or how there can be less bits. Uh, talking about subatomics, like when you get closer to the Earth, or how there can't be more bits that expel lightning or how there can't be more bits that expel fire, or photons for that matter, or how there can't be more bits that hold a rock together in place. And so I'm just not going to believe it. But yeah, because if you're talking about a scale in space, or you're talking about the moon pushing against something, then it's pushing against a scale. I'm not going to call that energy. I'm just going to say, yeah, it can be pushing. It can be in Earth's gravity. It could be in the rotation. I mean, so it just becomes. So yeah, yeah, yeah. Like I'm just saying. I mean, it's obvious. Like I'm wrong. It's obvious I'm wrong. There has to be a scale. There has to be like accurate measurement of mass to be able to understand an object and its weight. But then you're also saying that there's also subatomic bits involved, and those particles are invisible and indivisible. They're inseparable. And yeah, I'm not gonna go there. It's just come to that for me. So um, and then you have things like force and pressure, but yeah. So yeah, I mean, I'm just saying the anti-de-Sitter space and the anti-de-Sitter space. This is like kind of what I was trying to say with the Mellin transform is how the math just reflects. They just have math for cosmic boundary, and then they have their dependent math, which would be essentially like their Mellin transform or their Lorentz. It's like the anti-de Sitter space. They use Lorentz. So anyway, I mean, this has all become very docile, um, and yeah. Anyway, yeah. I mean, I'll just think of the quantum mechanics as um, little bits of sand and hourglasses and things like that. But yeah, I'm still not going to be able to figure out the cosmic soup. I mean, in um, there's still displacement in what am I trying to say? A string. So you still have to say, well, the string started from somewhere, and where there's curvature or boundaries and things like that, there would still be empty space in it. So you can't account for the neutrinos or the cosmic soup in that sense. But yeah, I mean, I totally get the point. I totally get the point. I'm completely wrong. Um, I'm just not going to prove. I'm not going to sit here and prove coronavirus. I'm just not going to do it. It's not my job to prove coronavirus. So anyway, um, yeah, the Mellin transform, and yeah, the anti-de Sitter spaces. That's right around the time Einstein leaves. Right around the time Einstein leaves Germany, and there's the debate between, well, actually, Heisenberg basically forms his, um, this, it's like this constant, like these constant things, like the Planck constant. Well, the anti-de Sitter space, which is this conformal field theory now, because they have they have mathematical equations that reflect or they completely are in codependence with other forms of like other measurements of gravity. So they don't make sense out of any of their hypotheses. Anyway, that was created around the same time as the Heisenberg uncertainty principle. So the Heisenberg uncertainty principle, yeah, it seemed to sort of have a grand effect, and then there's also a grand effect with the Bohr atom, which was like 3 years later. Um, so I don't know how the Bohr atom is any different, but my conclusions are that um, anatomically the Bohr atom can move outside of its properties. And before, when there was just Maxwell and de Sitter space or Lorentz or even Faraday, like these types of there was very specific boundaries that energy could either enter or not exit. So to my understanding, like the Bohr atom was kind of what elevated, so to speak, the nature of reality where these boundaries could exist outside of themselves. And that's something like where you would see like Newtonian field is flat and a Einstein field is bent because of those circumstances of the subatomics. So if there was more space, if there was more vacuum, then there was less subatomics and it would get stretched. So that's just relativistic. I mean, you can easily relativistically understand that, but does it make sense that, does it make sense to Rene Descartes? Like, is that like not good enough for Rene Descartes? I would say it's definitely not good enough for Rene Descartes because he's a Platoist, and Platoists need to have everything interconnected. They need to have zero separation, which I'm not buying. I'm buying relativity, and like uh, I'm giving back just whatever, like Cartesian, the stuff that everything is going in and out of everything. So, or then this idea that like everything is coming from nothing. I mean, what's the point of having a theory of everything and you're trying to uh, decide a debate or a conversation on the idea that everything is coming from nothing? Um, that's my problem. Is like that's just my inert problem that I have with everything coming from nothing, as do I have a problem with everything coming from everything. It's just like you're saying, well, nothing created everything, and then, well, that doesn't separate you from the idea that everything's in everything, or there's everything inside of everything, which is just a complete, like I said, a theological understanding of the universe. I don't give a fuck where it came from. I don't give a fuck where we came from. I know where I am, and I know the evidence that exists on Earth for what I am, and I don't need to have this philosophical like hierarchy of needs where like I'm somehow going to be, like I'm somehow elevating my consciousness because like I have a string theory. So it's no offense. I mean, trying to be I'm not trying to be an asshole, but it's just true. So, yeah, I guess shape matters to me a little bit, but if you say there's no shape, I mean, okay, the sun's not perfectly spherical, the moon's not perfectly spherical, Jupiter's not perfectly spherical. It doesn't make a difference. I mean, there's still that you can still see that it's a quanta, or it's a clump of energy that makes a spheroid shape. And that spheroid shape, whether it's described by Minkowski hyperbole or a Faraday uh, paradox or whatever, I'm okay with that. I'm just gonna say like your world is different than mine. We live on different worlds. Um, but yeah, when it comes down to Fermi paradoxes about aliens and all this stuff, no, I'm gonna shoot right to evolution. So that's just what I'm really going with. All right, yeah, I'll try to do the evolution and economics real quick. Just get this over with. Um, yeah, basically, all right, chronological selectivity. Um, so we're inching closer to, like 300 million years or 250 million years. You have like development of the monkey and then the chimpanzee. Um, then pretty close to the Homo sapien, and then you have Neanderthals. There's a theory that Neanderthals never interbred with Homo sapiens. I would say maybe for the long run, but yeah, again, this interbreeding thing is just really diversity. Yeah, natural selection, selectivity. Um, so they're a lot taller, and Homo sapiens were a lot shorter, and then now there's just Homo sapiens sapiens, and according to my knowledge, and yeah, one thing you could think about is like how um, each race of humans kind of say like, oh well, all of them look alike, or all of them look alike, or all of them look alike, or all of them look alike. I mean, it's kind of true in a sense. So in a way, I don't think it's full proof um, to say that we still have some diversification left if that's what we're choosing to do. If we're going along in a procreative nature, then yeah, we still have, I'd say, room for diversification since we don't really recognize all the other human races. Just as many fish could easily recognize another species of fish. So that's all I was really saying. I don't think we're different species. I think we're all the same species, but I do think that our uh, Homo sapien nature is just a little bit. There's like a little bit of variety. Um, so I do think that there is variations, and yeah, I mean that's pretty much my key. That's my key understanding is that there's variations and there's variance to earthbound nature and the physical universe. So yeah, I mean, but that sorry, that also takes about essentially 300 million years to get to Homo sapiens sapien, and then to my understanding, it's about a million years of mammalian survival to get to where we are now, and that's from 300 million years of well, yeah, they according to science, I think the Neanderthal went extinct. I don't know, 70,000 years ago, but yeah, I think about 70,000 years ago, and then well, at about 100,000 years, I think for about 30,000 years, it could have been some diversification with the Neanderthals, how they say it. Um, anyway, um, yeah, uh, yeah. So yeah. I mean, you just have like an extreme amount of selectivity, natural selection that could have gotten you the monkey or the chimpanzee, things of that nature. I think we're talking like there's an asteroid, and then there's like uh, more abundant. There's more abundant species in mammalia because they were that are hiding from reptiles, dinosaurs, and then slowly the dinosaurs go extinct, and we're still able to be herbivorous or frugivorous, and so we're talking about different plants, and we're eating those plants, and then uh, diversifying or interbreeding, and then eventually, moving, migrating. So yeah, and then yeah, pretty much just getting into this. All right, the economic management of resources, or economies and management of resources. So essentially, there's this, and I mean, I got a lot of this information off of Rational Sciences channel, and also was looking at debatephysics.com. And so, yeah, I'm just regurgitating essentially. But yeah. So, I mean, I disagree that, yeah, I think we could have diversified with the Neanderthals for quite some time before they would have fell off. Anyway, um, yeah, I think the story goes like the Neanderthals like were the ones that left the African savannas and they went to colder climates and then they just didn't survive. Essentially, that makes sense because the there was the freezing, like there was a cold global cooling, and there was an ice age, and the Neanderthals were extinct directly after that ice age, according to science. And so that makes sense, but I don't think that there wasn't any uh, interbreeding or anything like that. Um, so again, you have a bigger species involved with a smaller species, the Homo sapiens, and it just seems like the Homo sapiens were able to escape the wrath of the warmongering or whatever it was with the Neanderthals. Essentially, that's what the idea is. But I'm sure there was definitely interbreeding. So um, then you have, yeah, like, so now you have economics and was saying that there is, we just have kings and philosopher kings and things like that and people that we have to adhere to, like we're adherents. And um, the idea was that essentially when money runs out or when money doesn't work or when our digital currency is no longer, uh, then there will be a collapse. Essentially, our, well, the extinction of our species depends on the economic collapse or the digital currency collapsing because that digital currency means so much to us for um, our food supply, which I agree with, because we don't live within biodiversity anymore. I mean, it's just we've completely enabled ourselves, and the statistics of um, unemployment, not unemployment, but yeah, of humans seeking internet validation or working or employment through internet validation is, of course, at an all-time high, and other things like manufacturing have gone down, and that's what makes it really apparent that we're not losing anything as a species that, because it's only been like 200 or 300 years or 400 years. We're not like losing our instincts or anything like that. We're just overhauling our economy, and we've made ourselves too dependent on it. Like we used to use gold, and now we have this currency standard, which has just set us up for an extreme economic deflation, which makes sense. So the idea is that with these meta politics, that we somehow use meta politics, or it's like an instant runoff meta politic, you know, agreement, like social contract, is like meta politics in this way, and that somehow we go back to egalitarianism, and egalitarianism is of course just this um, sort of community standard that we're just helping and doing whatever we can. I don't really see. I mean, if the notion is that we're going to divert back to egalitarianism, I mean, we've never lived egalitarian before. Just, I mean, just like communally, like we've never lived really for long periods of time as communes. I would say it just doesn't work unless you have like a really big government and law enforcement everywhere and things like that, that you don't have to worry about like bandits and anarchy. So egalitarianism isn't really uh, what I think will happen. I mean, I tend to lean more towards like just Stalinism, and that the poor are going to be out of control. I don't really think there'll be a revolution, because we might just be too sick of a society to sort of understand that that's what we need, in order to get eat something like egalitarianism. But yeah, I don't think during a economic upheaval, like a economic complete deflation or a collapse of the economy, is going to lead to something as peaceful and pleasant as egalitarianism, or just everybody living on communes actually sounds. Um, yeah, because yeah, this pyramid elaboration that our economic management runs off of a pyramid that is eventually going to just invert. And so everything at the top of the pyramid uh, will be inverted to the bottom. And like essentially, if you have like egalitarianism now, like equal rights and everybody be good in the community now, that'll be completely flipped over on its side. Like whatever you think is the most important thing now in current economies, but like in our current pleasant economy, then it'll just be flipped on its head, slowly but surely. Like the least, important thing is almost essentially food, really, and so that'll become the most important. And we won't really have, especially in cities like 100,000 or more, you won't really have anything to be able to get that food. Essentially, in a some sort of upheaval. But I mean, you could see it in other countries first. It could be all over the news first. Um, like a real global economic collapse could happen very slowly. So I mean, it could happen over 20 years. I mean, there could be like just a some 30-year Great Depression. So yeah, I think that's it. Bye. Thanks for listening.